Donut Lab just released their second independent battery test. They heated their cells to 100 degrees Celsius and discharged it. And the numbers don't make sense. Not because the battery failed. It didn't. It actually gained capacity. The problem is that what we found in this data contradicts both sides of the debate. The people who think it a fraud and the people who think it's revolutionary. We went through every data point, calculated things that aren't in the report, and compared the cell against every commercial battery we could find. And then we went further. We pulled published research papers and dug into the company's own supply chain. And what we found took us to some genuinely interesting places. Let's together. So, if you're new here, Donut Lab is an Estonian-Finnish startup claiming that they've built a solid-state lithium-free battery that charges in 5 minutes and lasts 100,000 cycles. Oh, and it hits a 400 watt-hour per kilogram of energy density. If true, your EV would charge faster than you can pump gas. In our last video, we analyzed their first test with VTT, that's Finland's National Research Center, and found that their cell voltage fingerprint matches NMC lithium-ion almost exactly, 3.5 volts average discharge. Now, test 2 is out. Same lab, same equipment, but this time they cranked the temperatures to 80 degrees Celsius and then 100 degrees. One thing to keep in mind, VDD tested what Donut Lab gave them, following Donut's test plan, right? They're not out to prove anything or disprove anything. Donut Lab is a customer who asked to do these tests, and they did the tests. VDD tested a single cell labeled DL2 sitting in a climate chamber with a 2.4 kilogram steel plate on top. And now that's for pressure. We calculated to be around 0.9 megapascals. Real solid-state batteries need between 1 and 70 megapascals to make sure that there's good contact on the interfaces of the solid-state electrolyte. That's not what was happening here. This is very, very low amounts of pressure, just to, in their words, keep from any hot spots from being formed on the battery during testing. The same cell was used for every test. First, a baseline discharge at room temperature. A full 24.9 amp hours was pumped in. Then they heated the climate chamber to 80 degrees Celsius and let the cell soak for 2 full hours and discharged it at 1C. The cell delivered 27.5 amp hours. That's 110% of its room temperature capacity. It got better when it was hotter. Then the same cell was charged back up at room temperature, heated to 100 degrees Celsius for 2 hours while fully charged and discharged again, and 27.6 amp hours came out, 107% of the initial reference input. Now, the 100C test was at 0.5C, half the charge rate of the 80 degrees test. So, those two numbers aren't directly comparable, and it's interesting and worthy of note. Why they didn't do 1C at 100 degrees, I'm not sure, but it still beat room temperature input by a lot. After the 100C test, the pouch had lost its vacuum. It's visibly puffed in the VTD photos. And this actually makes sense mechanically. Standard pouch laminate uses a polyolefin adhesive to bond the aluminum layers to the inner polypropylene. The adhesive melts around 85.4 degrees Celsius. So, at 100 degrees Celsius, you'd expect the seal to be compromised, and it was. And Donut Labs actually calls this out. They make a point to note this. We can see that the active materials are still fine, because the cell operates normally even though the outside pouch has lost its vacuum in the heat. Now think about what that means. If this was a conventional lithium-ion cell with standard liquid electrolyte, a pouch breach at 100 degrees Celsius would be dangerous. The organic solvents in lithium-ion electrolytes are flammable. DMC is one of the most common ones. Boils at 90 degrees Celsius. So now you have flammable vapors, oxygen in the air, and 100 degrees Celsius temperatures. That's the fire triangle. The cell would probably catch fire, melt down, or at minimum be completely destroyed. But VTD charges back normally and the cell still worked. This tells us something fundamental about what's inside the cell. Either there's no flammable liquid electrolyte in there, or it's something very different from our standard lithium-ion chemistries. This is a kind of amazing engineering that keeps me up at night. And something else that keeps me up at night is protecting my personal information online, and why I'm a huge fan of our sponsor this week, Incogni. Information, your home address, phone numbers, even your relatives' details is being collected and sold online. It's not only lucrative, but totally legal. And this valuable data advertisers crave is the same data criminals use for everything from scam calls to identity theft and actual stalking. I signed up with Incogni because they work nonstop to constantly look for your personal information online and automatically request to have it removed. This is something that would take you and I hours, and it's not a one-time thing. It's an ongoing battle. If you give Incogni permission to act on your behalf, they go to work contacting hundreds of data brokers to get your data taken down. What really sold me was their custom removals feature. If you find your info on some random website, you just send Incogni link and their team handles getting it removed. I love the internet, but we have to be real about some of the dangers, and companies having access to your personal information is one of them. So, if you've been thinking about staying safe online and want to take back control of your personal information, go to incognitoN.com/2bit to get 60% off an annual plan today. Huge thanks to Incogni and you. Now back to the show. Now, if you're thinking any battery delivers more capacity when it's hot because there's lower internal resistance and ions move faster, that's basic airness kinetics. You're right. That's not special in and of itself. So, we tried to find a single commercial NMC battery cell from Samsung, LG, CL, really anyone with published discharge rates over 80 degrees Celsius. And we couldn't find a single one because, well, they don't test in that kind of regime. Samsung's maximum rated discharge temperature is 60 degrees Celsius. Most manufacturers cap at 45 degrees. The closest study we could find was from Yalonen and colleagues, a commercial Cocom-40A NMC pouch cell that cycled at elevated temperatures at 65 degrees Celsius. The cell was destroyed. The donut cell delivered 110 capacity at ADC and kept going to 100. We can't even find published data for what happens to a normal NMC cell at these temperatures because manufacturers don't really test there. It's too dangerous. But there's more. We calculate the caloric efficiency for every cycle. That's the ratio of charge out versus charge in. One of the most diagnostic measurements of battery science. At room temperature,